Hello and welcome to my video on covalent bonding. In this video we'll be covering what covalent bonds are, electron dot and cross diagrams, polymers, and finally the properties of covalent compounds. Unlike ionic bonding, which involves the transfer of electrons from one atom to another, covalent bonding involves two or more atoms sharing their outer shell electrons in order to achieve stability. Covalent bonding only occurs between nonmetals such as nitrogen, chlorine, and oxygen. All atoms want a full outer shell of electrons, as this is when they are most stable. Examples of covalent molecules include water, carbon dioxide, and chlorine gas. We can represent covalent bonds and molecules using a dot and cross diagram, which allows us to see the number of shared electrons there are and where electrons have come from. For example, in its molecule bromine, we can see that one pair of electrons is being shared, with one electron coming from each bromine atom. Drawing dot and cross diagrams looks difficult, but it's actually quite easy. First, you will need to write down the chemical symbol of the atoms involved. So for a molecule of chlorine, we would write down 2 Cls. Next, we will need to work out the number of valence electrons each chlorine has. In chemistry, valence electrons are the outer shell electrons. And since we know chlorine is in group 7, we know each atom will have 7 electrons in its outer shell. Once we have worked out the number of valence electrons, we will then need to assign dots and crosses to each atom. This helps us to keep track of where electrons have come from in the covalent bond. We will draw crosses for one of the chlorine's outer shell electrons and dots for the other. Drawing each chlorine atom's outer shell electrons, we can see that each chlorine only needs one more electron for a full outer shell. So each chlorine shares one electron, allowing it to have a full outer shell. As a quick recap, dot and cross diagrams are useful as they allow us to see the number of shared electrons a covalent bond has and where the electrons have come from. Covalent molecules and compounds can also be represented using a display formula, where the lines represent covalent bonds between atoms. Display formulas are good for representing large covalent compounds or molecules with lots of bonds. For example, propanoic acid would be difficult to draw using a dot and cross diagram. Another way covalent molecules and compounds can be represented is by using a three-dimensional diagram. 3D diagrams are excellent for showing how atoms are arranged in space. For example, methane would look a little bit like this, whilst water would look a little bit like this. Polymers are long chains of carbon atoms made from repeating units known as monomers, where lines represent strong covalent bonds between atoms. Covalent compounds have lower melting and boiling points than ionic compounds. But why is this? Well, despite covalent bonds between atoms being very strong, the intermolecular forces between molecules is relatively weak, which means less energy is required to break the bonds between molecules, reducing its boiling and melting temperature. If you found this video useful, please do subscribe, and I look forward to seeing you next time.